Today is a nice fun challenge. Find the greatest common factor of the terms of each polynomial. Greatest common factor, again, is the largest thing that goes into each of these terms. So if you look 12x squared and 6x, if you just think about the numbers 12 and 6, you're probably thinking, hey, 6 goes into both of those, and you'd be right. That is the greatest common factor between 12 and 6. Do they both have x's? Yeah, they both have at least x to the first power. So you would just say 6x. If you look at number 2, first thing I notice is they all do not have an m. So at most we can just say a number, an integer here. 28, 35, and 14. I know that 7 goes into all those. Look at number 3. Do they all have v? No. So again, it's just going to be a number. 4, 36, and 10. The largest number that goes into all those is 2. All right, and then factoring trinomials. Remember, when you're doing this, you look at the last number first. Multiplies to positive 4. When it multiplies to a positive, they're either both plus or they're both minus. So then you look at the first symbol. If they're both plus or both minus, and they have to add up to positive 5, you're like, okay, obviously that's both plus. So we're looking for factors of 4, which could be 1 and 4, or 2 and 2, that add up to that middle term, 5. That would be your 1 and 4. Cool. You look at number 5, and it ends in minus. The only way you can multiply to a negative is a positive times a negative. Now, we're going to need them to be 3 apart from each other, and they have to add up to negative 3, which means our big number will go with the minus. That's the only way they can add up to a negative here. So 1 and 28, 2 and 14, or 4 and 7. Which set is 3 apart? That'd be the 4 and 7. So it'd have to be, because it adds up to negative 3, negative 7 and positive 4. Looking at the last one, it ends in plus. So they're both going to be plus or they're both going to be minus. If I look at the first term, it's negative. So that would say they're both negative. T minus, T minus. And anytime that last term is plus, they have to add up to the middle. So thinking of 30, 1 and 30, 2 and 15, 3 and 10, or 5 and 6. Which set adds up to the 11? That would be your 5 and 6. If you can do that, today shan't be a problem. There's kind of 2-ish new steps on it. So today, we're going to have numbers in front of the x squared, which we've never had before after we took out a greatest common factor, which is still always your first step. You should always look for, is there a greatest common factor to take out? Which if you look at this example, 6, they all do not have an n, so is there any number that goes into 6, 23, and 7 except for 1? No, there's not. So here's what we're going to do. If you look at step 1, factor out GCF if there is one. Step 2, multiply AC. That's your first term times your last term. So we're going to do 6 times 7. And it's 6 times positive 7, which is positive 42. We're going to think of all the factors of 42. That could be 1 times 42. It could be 2 times 21. It could be 3 times 14. Or 6 and 7. That's it. So then it says step 3 is find the factors of AC, what we just did, with a sum of B. Do any of these sets add up to 23? That would be the 2 and 21. So we set it up like we ordinarily would here. This would ordinarily be both plus 2 and 21. Now, if you were to FOIL that out, it's not going to give you the original problem. And it's thrown off from that 6 in front. So here's the new step. We're going to have to try to divide each of these terms by the number in front, the a. So we're going to try to divide them both by 6. Now, here's the wild part. Neither one of these are divisible by 6. However, both of those fractions can be simplified. If you look at the fraction 2 over 6 and you're like, what goes into 2 and 6? 2. So we're going to divide them both by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. We're going to do the same thing over here with the 21 over 6. I know that 3 goes into both of those. 21 divided by 3 is 7. 6 divided by 3 is 2. Here's the last thing we have to do. Whatever you end up with in the denominator, we're going to swoop, bring it out in front of the x, or in this case n. So this 3 down here, we're going to bring right in front, and that's going to become 3n plus 1. Over here, the 2, we're going to bring to the front, and it'll become 2n plus 7. Now, if you were to FOIL this out, this is our final answer, by the way. 3n times 2n, 6n squared. 3n times 7 is 21n. 1 times 2n is 2n, and 1 times 7 is 7. This would give us 6n squared plus 23n plus 7. OMG, that's what we started with. This is what I think is the quickest, most efficient, simplest way for a lot of people to grasp factoring when a does not equal 1. Let me show you another way. This is the way the textbook would show you how to do it. I think you're going to prefer my way. I learned that back in the day from a 7th grade student in Florida, and I love it, and I've never gone back. But let me show you another tool for your tool belt. A lot of the same first steps. You multiply first and last, you get your 42, and you still think of your factors of 42. 1 and 42, 2 and 21, 3 and 14, or 6 and 7. You're still looking for the set that adds up to the middle, which would still be 2 and 21. So what we do is, this is called factoring by grouping. So we're going to split this 23n. We're going to split it into two terms. We're going to split it into 2n and 21n. And honestly, it doesn't even matter which one you write first. So we'll say positive 2n and positive 21n. We're going to bring down the other two terms, the 6n squared, the plus 7. And now that we have an even number of terms, we can factor each half. So what I like to do is kind of draw a squiggle down the middle here. And I look at the left side and I'm like, 6n squared and 2n. What do they have in common? They both have 2n. So I factor out the 2n and I'm like, oh great. 2n times 3n gives you 6n squared. And 2n times positive 1 gives you 2n. Not too bad. We're going to do the same thing on the right side. 21n and 7, they both have a positive 7. 7 times 3n is 21n, and 7 times positive 1 is 7. Now, if you look at both sets of parentheses, they both have the same thing, the 3n plus 1. That's part of your answer. The other part of your answer is the greatest common factors that you took out, the 2n plus 7. Now, you may notice that's the exact same answer we got the other way. It works this way, and it's a lot of overlap on the steps. You still multiply first and last. You still find the ones that add up to the middle. From there, it's just kind of like a little bit different. But choose your own adventure. I'm going to keep practicing the first way in this video, but in class, if you'd like to work with me on the factoring by grouping method, I'd love to. I'm totally cool with that. Let me just see where we're at. Okay. Always look for a greatest common factor. I'll just let you guys know there is no common factor on any of these except for 1. So then we're going to multiply first and last. 2 times positive 2 is positive 4. I know that if it multiplies to a positive, they're either both plus or both minus. Looking at this problem, the first term is plus, so I know they're both going to have to be plus. I'm thinking factors of 4 could be 1 and 4 or 2 and 2. Look at that middle number, 5. You think I'm going to use 1 and 4 or 2 and 2 for 5? Obviously 1 and 4 because they add up to 5. There's one more step after this. We have to try to divide by a, the number in front. So we're going to try to divide them both by 2. Now 1 over 2, we can't do that, and you can't simplify that anymore. So you just bring the 2 to the front, and it becomes 2y plus 1. The second fraction, you can do that. 4 divided by 2 is 2. So you could make it 2 over 1 and bring the 1 to the front, but it's unnecessary. If it divides evenly, just write it as y plus 2. Done. That's it, man. Now, there's a lot of, if you look at the initial problem we started with, it was basically this, except that 23 was plus. So, it's basically the same problem. Except the only difference is they multiplied a positive 42 and they add up to negative 23. That just means they're going to have to both be minus. So it would be n minus, n minus. And the factors of 42 that added up to 23 were 2 and 21. We try to divide them by the number in front, the 6. Neither of these can divide by 6, but they can both be simplified, just as we did on the first problem in the notes today. 2 6 becomes 1/3. We'll bring the 3 to the front. That makes it 3n minus 1. 21 over 6, we divide them both by 3. That becomes 7 over 2. The 2 will move to the front. 2n minus 7. Cool. And again, C, strikingly similar to A, except the only difference is the minus. So this one, it's going to be the exact same thing except minus minus. 2y minus 1, y minus 2. I would rather spend our time going over a different problem with different numbers instead of doing the same problem twice. Now, this one, if you look, 20x squared, 80x, 35, all of those are divisible by 5. So you have to take out the greatest common factor first. Mandatory. So we're going to take out the 5, and we're going to divide each of these terms by 5. 20 divided by 5 is 4, so we have 4x squared. 80 divided by 5 is 16, and 35 divided by 5 is 7. Now the nice thing about this 5 on the outside is we could pretty much ignore it until our final answer. It just stays on the outside. But what I see a lot of kids do is they'll factor it out and then they kind of forget about it and they forget to write it in their final answer. So that's why I usually just write it right away so I don't forget. Now we're working on the inside of the parentheses. Look at those signs. It's plus plus. I know that means my breakdown is going to be plus plus. So we do our 4 times 7 first, which is positive 28. We need a set that adds up to 16. So we have 1 and 28, we have 2 and 14, or we have 4 and 7. We need the set that gives us 16, boop, 2 and 14. Doesn't matter which one you write first, because they're both plus anyway. We're going to try to divide them by the number in front, the 4. Neither of these divide evenly, but they can both be simplified. 2/4, we know, is 1/2. The 2 will come to the front, 2x plus 1. 14 and 4 are both even, so we could divide them both by 2. That will give us 7 over 2, and the 2 will come to the front. 2x plus 7. Whew. Now, if you're wondering how you could check this if this was your final answer, couple options. You could multiply the 5 times either one of these sets of parentheses. You would just do it to one of them, and then you could FOIL those out. Or what I would actually do if this was me is I would FOIL out the parentheses stuff first, and then multiply it by 5 at the end. So if we FOIL this, 2x times 2x is 4x squared. 2x times 7 is 14x. 1 times 2x is 2x. And 1 times 7 is 7. So if we combine our like terms there, that would give us 4x squared plus 14x plus 2x is 16x plus 7. And then I would multiply them by 5 at the end, which would give me 20x squared plus 80x plus 35. Oh, that's what we started with. Are you kidding me? Are we just this good at factoring trinomials where a is not 1? Dude, this is a struggle for a lot of high school students. Once you throw that number in front, real tough. Here we go. We got 2 of them here. always look for a greatest common factor first. I see this first one has a 2 in common. So I'm going to factor out the 2, which leaves us with v squared minus 6v plus 10. Now, this is boring because this is like an old problem now. There's an invisible 1 in front of the v squared. You could just do it the old way, but let's pretend like your brain only has space for one method of factoring. So do it the way we're doing it today. You could still multiply first and last. 1 times 10 is 10. And it's positive, so they're either both plus or they're both minus. If they add up to -6, that means they have to both be minus. Factors of 10 could be 1 and 10 or 2 and 5. Oh, geez, I forgot to divide the 10 by 2. Guys, you can't take me anywhere. My apologies. So that should have been a 5 if I divided it by 2. Oh boy. So then if we did 1 times 5, it's 5. So our only options are 1 and 5. Boop, boop. And then you're like, shouldn't we try to divide them by the number in front? Yeah. We could divide them both by 1, but 1 divided by 1 is 1, 5 divided by 1 is 5. So it wouldn't change anything. Now, I did forget something. That's not a perfect final answer. Can you see it? Nice. Yeah, the 2 on the outside that I factored out earlier, that should be on the outside still. All right. Now, on B, they're all divisible by 2 again. So we'll factor out the 2 first, which leaves us with 2y squared plus 7y plus 3. Whew, I remembered to divide them all. Don't forget that 2 on the outside will be in our final answer. Look at those signs, though. Let's start being forward thinkers here. It's plus plus. So is our breakdown going to be both plus, both minus, or one of each? If it's plus plus, that means our answer is going to be plus plus when we factor it. So we multiply our first and last, our a times c. 2 times 3 is 6. Factors of 6 could be 1 and 6 or 2 and 3. Our middle number is 7. The only set that adds up to 7 is the 1 and 6. But we do have to try to divide them by the number in front. Now, when I say the number in front, I mean the number in front of x squared, or in this case, y squared. And yeah, the number on the outside happens to be a 2, but that's not the 2 we're dividing by. We're dividing by the number right in front of the x squared. And again, in this case, it's y squared. So we're going to try to divide them both by 2. You can't do 1 divided by 2, so we just bring the 2 to the front. 2y plus 1. I can do 6 divided by 2. That's just 3. Y plus 3. All right. From what I remember, I think there's 3 problems here to try out. I'm going to do all 3 of them here on video. I'm going to do them quickly, though. I'd recommend pausing it and trying out at least 2 of them. Give it a whirl. I'm going to do them up here. Do your best. Two times 7 is 14. 1 and 14. 2 and 7. We're going to use 1 and 14. They have to both be plus. We have to try to divide them by the number in front, the 2. I can't do 1 divided by 2, so the 2 moves to the front. 2n plus 1. I can do 14 divided by 2. It's 7. All right. 7 times 7 is 49. 1 and 49, or 7 and 7. The ones that give me that middle number would be the 1 and 49. They're going to have to both be plus on this one, too. How fun is that? We do have to try to divide them by the number in front, the 7. I can't do 1 divided by 7, so the 7 moves to the front. 7d plus 1. Here, I can do 49 divided by 7. It's just 7. All right. 11 times 3 is positive 33. So it could be 1 and 33, or 3 and 11. Those are our options. Now in this case, multiplied to a negative or positive, but that adds up to a negative. So they have to both be minus. The set that adds up to 14 would be the 3 and the 11. We have to try to divide by the number in front, 11. You can't do 3 divided by 11. You can't even simplify it. So the 11 moves to the front. 11w minus 3. Here, 11 divided by 11 is 1. Look at us, we are factoring pros.